Good examination questions really get students thinking about the underlying concepts. This one is a good question, so I'm going to spend a bit of time really explaining what's happening. Let's start with this simple question: define capacitance. It's tempting to go straight in with capacitance equals charge over PD, and that would get the mark, but it's not ideal. What if we are referring to an isolated conductor? What would the PD be? There's nothing to compare to, so a subtly better answer is to say that capacitance is the ratio of charge and potential. Next up, a 4-mark question to explain why we say that capacitors store energy, not charge. So let's start with an uncharged capacitor. 2 metal plates. I'm going to connect the plates like so. No cell, just a wire. The total charge on the capacitor is 0. If I take a charge, move it round the circuit like this, and put it on the other plate, I'm doing work to move the charge, and the capacitor still has 0 total charge. Move another one, I'm doing work again, but the total charge is unchanged. It's that idea that we are doing work to move the charge that most people miss out on. So let's summarize that. The capacitor has 2 plates that hold equal magnitudes of positive and negative charge. The total charge on the capacitor is always 0, so it's not storing charge. To separate the positive and negative charges, work has to be done. The capacitor is storing this energy as potential energy. It has the potential to discharge. Next, we have a relatively simple question to calculate capacitance. You just need to remember the formulas which are reversed from resistors. So the 2 in parallel give a total capacitance of 12 plus 12 equals 24 microfarads. Then that in series with another 12 microfarads, so 1 over C equals 1 over 24 plus 1 over 12, giving us 8.0 microfarads. Next, explain why, when the PD of 9 volts is applied, the charge on one plate of the capacitor X is 72 microfarads. And we've got the same circuit here still. So for this question, we need to show that the charge is 72 microfarads. We can just use Q equals CV equals 8 times 10 to the minus 6 times 9, which comes from our previous answer and the PD here. Careful that you don't just write 8 times 9 here, ignoring the power of 10. But that only gets 1 mark. Can you think why? Thinking time. Well, the question is actually asking you to explain why. It's a bit forced, this question really, but they are trying to get at the fact that a capacitor actually has 0 charge still, and that although the charge is spread across Y and Z, it is focused on X. So, I'm going to write that from the calculation for an equivalent capacitor, the charge is 72 microfarads. all of the charge of one sign, either negative or positive, will be on the left plate of capacitor X. The same magnitude of charge of the opposite sign will be distributed across the right plates of capacitors Y and Z. It's tricky, very tricky. Okay, on the next one, there's a lot of students struggle with this question, which might surprise you because it's only 1 mark. All you need though is the capacitance equation, C equals Q over V. Let's rearrange that, V equals Q over C. Okay, the charge was given as 72 microcoulombs and C equals 12 microfarads. So V equals 72 times 10 to the minus 6 over 12 times 10 to the minus 6 equals 6.0 volts. And finishing off, we want the charge on one plate of one of the capacitors in parallel. Well, there are 2 approaches. I would simply state that the charge is shared equally by the 2 capacitors in parallel, quoting Kirchhoff's first law if I had to, and then answer 36 microcoulombs. Done. Alternatively, the PD is shared by X and the parallel pair. Since X has half the capacitance of the pair, and V equals Q over C, and Q is the same for X and the sum of the pair, X must have double the PD of the pair. Since we know X has a PD of 6 volts from the previous part, that means the pair has 3 volts. So the PD across Y is 3 volts. Its capacitance is 12 microfarads. Q equals CV, so 12 times 10 to the minus 6 times 3 equals 36 microfarads. So there's the answer to a fairly long capacitance question. Make sure you understand the answers, but also try to understand where the theory is coming in to explain those answers.